Right, this is the 2016 TMUA paper 2, and we're looking at question 18. So, this comes under one of these logic topics, and the first thing to note is that there is a requirement for any function that is going to be a counterexample. So, what we're saying is f of x for all x's between -1 and 1 has to be less than or equal to 1, so that when we square it, it's also less than or equal to 1. Now, when you look at the idea of the counterexample, you might be tempted to focus on this, because this is obviously a very important part of what we find in the counterexample too. But we've got 6 options, and actually we could probably write off quite a few just by looking at what's in green. So we can see here, when x equals 1, well, f of 1 equals 3 over 2, so that's clearly not going to work. And similarly here, we've got f of -1 equals -3 over 2, so that's not valid because it doesn't fulfill the requirements for the function, because part of what we're trying to find in the counterexample includes this green bit. If we then look at C, we can do f of 1 equals 2, so that's gone. And E, similarly, f of 1 equals 2. So very quickly, we've written off 4 of the options. So then we're looking at D or F. Now, different people look at it in different ways, but one thing that I noticed straight away is in D, the function has odd powers, whereas in F, the function has even powers. Now, something that's not included on the spec anymore in A-level is odd and even functions. Now, if we were to, I'll talk about that in a second, but if we were to sketch D, what we'd have is that, well, D is x into 1 minus x squared, which of course is going to have roots at 0, 1, and -1. And because it's a negative cubic, it's going to look like that. But that there should be symmetry. That area there is the same as that area there. And when we look at F, we've got, well, that's going to be x squared into 1 minus x squared. So we've got a repeated root at 0. It's a negative quartic, so it's going to look like that. And we know, of course, it doesn't, well, we need f of x to be below 1, but that doesn't particularly matter, because if we look at D, this is f of x. But if you imagine squaring that, when we square it, we're going to have a symmetry, because this is an odd function. With an odd function, that means that f of minus x equals minus f of x. And so if you've got an odd function, you can see that when we replace x with minus x, it's the same as multiplying y by -1. So you're then going to have something that looks like this when you square it. So that's definitely going to be positive. The integral between -1 and 1 of f of x squared dx for this is definitely going to be greater than or equal to 0, whereas the original integral, the integral of f of x between -1 and 1 dx is equal to 0. So clearly that's a counterexample, just purely because the integral of f of x between -1 and 1 is equal to 0. So that's our counterexample, and we can then just not really worry about f. Okay, hope that helps. Contact me if you have any further questions.
Okay, can I make a